and the Visual Studio Code extensions for Salesforce developers. So those are going to be the main two tools I am going to be using today to start writing functions. And obviously, we will need to have an org. There are like two different ways to approach functions. One is a local development experience. So you will be able to create functions and integrate those functions with a developer org or with a Scratch org. It doesn't matter. But you can only trigger a function from the CLI. So you will not be able to deploy a function to a compute environment or to the platform. And the other one is if you have access to a functions enable org. This means that you have a functions license. If you have a functions license, you will be able to deploy a function to a compute environment and trigger this function from Apex and integrate it with your application. So either way or the other, you will be able to start learning and working with functions, but we are going to be covering the two. Like how can you do it? Local development with functions, and later, how can you deploy a function to a compute environment? How that sounds to you, Stephan?
Yeah, perfect. I think that's probably, before we even get the question, the number one question that people are asking is how they can actually get started, how they can begin to use and write functions in their own environments instead of watching us on these videos show them how to do it. They want to actually get their hands on the technology. And awesome. So getting started with the local dev is perfect.
Fantastic. So there is a great resource we published this week. You can go to the Salesforce Developers blog, and I created this tutorial. It's called Getting Started with Salesforce Functions Locally, No License Required. It's pretty much what I'm going to be covering here. I will be doing it pretty fast. I'm not going into like any details, but if you want those details, if you want a full example, go ahead, take a look at this blog post, and you will be able to start writing functions today. But let's do it live, right?
Yep.
So here we are starting with a Salesforce project. This project, it's a typical Salesforce DX project. It doesn't have anything extra. But since later I'm going to be deploying this also to a Salesforce functions enable org, the only thing I did was create a Scratch org with the functions feature. This is only possible if you have a license. If you don't have a license, you don't need to do this step, like adding the functions feature to the Scratch org configuration. The rest is going to be the same steps. So make sure that you have SFDX installed. So I'm going to be executing SFDX version to see that I have SFDX installed. Make sure to update to the latest version so you can have the latest Salesforce CLI, which is the SF command. The SF command represents the unified CLI, which is a project that it is aiming to get all of the different Salesforce CLIs under one command. And all of the functions experience, it's part of this SF command. So you can run SF version to make sure that you have SF installed in your computer, and also run SF plugins. I did a typo here. Run SF plugins to make sure that you have the functions plugin installed. This is what you need. You need SFDX, SF, and the functions plugin installed. And now we can start writing functions. You can do it two ways, using the CLI or using Visual Studio Code. And you can write functions using either JavaScript, TypeScript, and Java. JavaScript and TypeScript are going to be written using the Node.js runtime. So you will be able to install any dependency from NPM and use any API available on the Node.js ecosystem. And Java It's going to use all the Java ecosystem. You will be able to use any third-party dependency that it's published on the Maven registry pretty much. So you have access to a lot of different open source libraries and modules to extend your applications on platform, which is one of the main features and advantages of using Salesforce functions. So let's create a function using the CLI. Let's create a JavaScript function using the CLI. And then let's create a Java function using Visual Studio Code to show you the difference. So how can we create a function from the CLI? We are going to use sf, then the subcommand generate. We are going to tell the command that we are going to generate a function, and I need to specify a name. This is going to be my JS function. This is any name. It needs to be lowercase. And then I'm going to be specifying the language. The language here is going to be JavaScript. When I execute this command, this is what's going to happen. It will create a functions folder in my project, and here I'm going to be finding my new function, which is called my JS function. And if you open that folder, it is going to be a Node.js project. You recognize that it is a Node.js project because you have a package.json, which includes like the description of this specific Node.js project and all of its dependencies. And you have an index.js file, which is the file that contains the function. So the function is just a JavaScript function that receives 3 parameters: the event, which contains the payload, the input of our function, the context, which contains the authenticated context with the Salesforce organization, and the logger, which is an utility to log information on the compute environment or your local computer. And that function that we are exporting pretty much does all of these compute operations and returns a value. That's pretty much a JavaScript function. If you see here, from the context, I have access to my authenticated org, and in the authenticated org, I have access to the data API. So the data API is the interface I have available to be able to perform CRUD operations against my org. So this is how can I integrate this function with the org. I can do queries, I can create records, I can update records, and I can also use something called the unit of work pattern that allows me to have a transaction, like CRUD operation transactions within this function. And internally, this is going to be using the graph API, and it's going to be super performant, but that's going to be abstracted for you. You don't need to complicate yourself of learning and understanding how this works internally. Pretty much this is an interface that is being given to you. And the context is already authenticated. You don't need to create any JWT token or do any configuration setup. If your project, if you are already logged into your org here in your project, you can now trigger the function and get information from that specific org. If you see here in Visual Studio Code, I am already authenticated to a Scratch org called AMA functions that I created previously to this live. So we had something ready to show you. I have the function created locally. The next step I need to do is to run this function. So to run the function, I'm going to be executing a command. It's going to be also using sf, and the function is going to be running locally. As of today, we need Docker to be able to run this function, but our team is working on a containerless solution. So in the near future, and this is going to be before January 31st, you will be able to run functions without using Docker, for example. So it's going to be experience more friendly to developers. But today you will need to have Docker in order to have a local development experience. Do you have any question?
We do. We actually have our first
Awesome.
question through from Phil W. And he wants to know when functions will be packageable. So this is a question we get from a lot of our ISVs quite frequently.
That's a great question. And indeed, they will be packageable. It is on the roadmap, but there is not a target date yet. It is something that it's very in. I mean, there is a huge interest from the functions team to be able to have this feature and the capability of have functions package. But as of today, there is no like a target date for having this. So we don't know when this function is going to be when this feature is going to be available, but it is on the roadmap. Okay. And feel free to keep asking questions. Go to the Trailblazer community group or go to the YouTube chat as well and ask us there.
Perfect.
So we have the code locally. I want to run this function and I want to trigger this function locally. So before running the function, what this function do? So it is using the data API to perform a query against the org. It is selecting the ID and the name from the account object, and then it is returning that value. Okay, that's pretty much what it's doing. What I want to demonstrate here is that from a function, you can access Salesforce data. So let's run the function, sf run function, and then I'm passing the start command. So with the start command, what's happening is that this JavaScript function, oh, cool. I love when I get errors live. You need to execute that command on the functions folder. So let me go to the functions folder, to the specific my.js function. So the command says that it doesn't find the project.toml, which is the function definition that we have here. So awesome. And now I can execute the function start. Now it will start building the function. So what's happening is that it's taking this code. Internally, it uses build packs, which is the same technology that Heroku uses to build container images. It builds the function and runs this function on a container. So this is going to take some time while it runs. This is why I mentioned that the team is working on a containerless pretty much alternative, so it doesn't take that much time locally. When you deploy this function remotely, it will come through this whole process, but we have like a cluster of build servers that is going to take this operation more faster. So it is building the node project. It is going to run the function. The function is going to be running locally. And then using SF, I will be able to also invoke this function and get the value. So it will trigger the function. It will connect to the org. It will perform the query and it will return the values. While this runs, Stephan, do we have any other question?
We do. It'd be worth covering again quickly what languages Salesforce Functions supports. And so, as Julián mentioned earlier, currently you can write functions in JavaScript and TypeScript that are both running in the Node.js runtime and Java.
Exactly.
There are more on the roadmap, but please let us know what languages you would like to see in functions so that we can communicate that back to the product team to see where demand is when they start prioritizing other languages.
Yeah, please let us know what do you want to see. We know that there is on the roadmap. We don't know exactly when this is going to be fully supported, but Python is another language that has caught a lot of interest from the community and other of our customers. So it is something that it's on the roadmap and might be getting added into the project in the future as well.
Yeah, and we have one more question from Satya, asking how to get prior field values. I'm assuming in this case in functions. And the way that you would do that is via Apex. When you have a trigger that's running and you want to call your function from a trigger, make sure that you're passing anything that you want in the function from your class into the function. So if you have those old values available for you, you can pass any of that data into the function. But ensure that that data is coming from Apex. And so you have access to that in the trigger itself.
Okay, as I mentioned, I love when this happened live. Another error. It tried to run the function, but I already had another function running from 6 days ago because I've been writing functions for a while. So what I did is with Docker, I killed that process, which was called YouTube stats. You might recognize that from the blog post we published a couple of days ago. And I'm using Docker PS to check if I don't have any project running. I don't have any project running, so I will be able to execute a sfrun function start again to start my function locally. So it already has some images on the cache, so it will not take that long. Any other question while this runs?
Yeah, I have a question from Sarvesh around Lightning Web Components and their life cycles. And we're not set up to demonstrate any LWC stuff during this AMA. However, if you make sure your questions in the Trailblazer community, I can go back and share the relevant documentation with you that has the lifecycle hooks that you can hook into in that web component.
Please. And to have that question a little bit tight with what we are doing today, you can trigger functions from Apex. As of today, it is the main way to trigger functions. So you can easily have a Apex function exposed to a Lightning Web Component and trigger a function from Lightning Web Component. But in the roadmap, we are working on wires. So pretty much you will be able to wire a Lightning Web Component directly to a function call. So that's something that is coming into the roadmap. So you will be able to integrate Lightning Web Components with functions on an easier and faster way. Awesome.
Perfect. It looks like we have one more Lightning Web Component question.
Yes.
About why you should use, why you can, sorry, I'm just reading through the question. Trying to understand why Lightning Web Components only have one JavaScript file. And I would say, again, if you want to ask that question in the Trailblazer community, we can get you the correct answer there and the best practice for writing Lightning Web Components.
Yep. Remember, today we are talking about Salesforce functions. So if you have any Salesforce functions related questions, please go ahead and ask. We are not covering Lightning Web Components. That was covered in the previous AMA. But you can go ahead, as Stephan said, to the Trailblazer community group and ask your question there. We will make sure to go and reply from there. So, Stephan, this is working. This is running right now. I have my function running locally. So let me invoke it. Let me see how can we get values. So I'm going to be opening another terminal here. Let's do a split view. And let's invoke it. I'm going to execute sfrun function. I will be passing the URL. So locally, this function is a web application that is running on port 8080, as you can see here from the output. And then you need to always pass a payload. Remember that the payload is the input of the function. And this payload is JSON encoded. So you will need to pass a JSON. It could have any structure. I think it has a maximum of 3 megabytes. So you will be able to have a big payload passed into a function. And it will get processed. This function doesn't expect anything. So I am passing an empty JSON object. I will execute it. It will see that I am connected to an org. So it is using that org as the target organization here to get the information, which is the AMA functions, as you can see from my Visual Studio Code, and is executing the query and giving me the result. So pretty much I am getting an account which the following fields, the ID and the name. which is the query I specify in my function code. And that's how can I create, execute, and invoke a function from the CLI. How can we do it from Visual Studio Code? Let me show you. So let me close here. Let me make sure that I don't have anything running. And we can start again. Let me close this terminal. And I will show you how to create a function. This time it will be a Java function from Visual Studio Code. So I will open the command palette in Visual Studio Code. In Mac, it is with Command-Shift-P. In Windows, I think it's Control-Shift-P. And then I will write create function. This is showing us the Salesforce DX tools for Visual Studio Code. So I am running create a function, give it a name, my Java function, pick up a language, in this case it's going to be Java, and it creates a Java function. So you can see that we have a Java function here. So what is the structure of a Java function? So the Java function, since Java is an object-oriented and a strong type language, we are going to be having more files than just the single JavaScript file that we get from a JavaScript function. So we have the main one, which is the function class. This is my Java function. As you can see from the code, this implements from an interface, which is the Salesforce function interface. That it's what in Java it's called a bifunction. It's something that implements on two different types. So we have a function input and a function output. The function input represents the type of the payload that the function is expecting, and the function output, it's the type of the values that I am returning back. In JavaScript, it is dynamic, so I can pass any input and it will return any output. But in Java, I need to be a little bit more specific. So function input in this case is an empty class. So I am expecting an empty object. And the serialization is going to be done automatically. So you don't need to worry about serialization in here. And the function output, it is a class that returns a list of accounts. And what is an account? An account is a plain Java object or a POJO that has the ID and the name. So those are the three extra types that I need from this specific function. But if you see the Java function class, it's pretty much the same as the JavaScript. I have two inputs, like the event, which is the one that contains the payload, and the context, which has access to the authenticated Salesforce context. And I have a logger. The logger in this case is just a standard Java logger. I am using log4j in this case. But the event and the context has the same interfaces as in JavaScript. So here I am going to execute the same query. This is the same example. So I'm getting the data API and I'm executing a query. Select the ID and the name from the account object, get all of the records. Now I have a list of records, and then I will need to create my output, which is the function output. So remember that the function output has a list of accounts. So I need to create a list of accounts, do an iteration, get the different fields from the record, and then I return the output. So Java is a little bit more, it has more code, but it is strongly typed. So it will be suitable for certain developers that are more familiar with this type of languages. I show you how to create the function from Visual Studio Code. How can we run the function from Visual Studio Code? The same, we open the command palette and we execute a start function. So start function, now it is running this function from Visual Studio Code. And this will take also time. It will detect that this is a Java project, and it will start the building process and running on a container. And as you can see here from the output. Meanwhile, this runs. Do we have any other question, Stephan?
We do. Yeah, we have a great one actually coming from Bill K. So, Bill has asked if ISVs will be able to leverage functions. He missed it the first time. And so the answer earlier was just that it is currently something that we want to support. There isn't a hard date on the roadmap, but obviously something that is of top priority to us. And then a great question from Ravi is, what's the difference between hosting a web service in Heroku and calling it via the API or WebSockets versus calling a Salesforce function from Apex?
Oh, Ravi, that is a great question, and I am glad you asked. So even though they might look somehow similar, those two things solve different problems. So an Heroku application is an application that is constantly running and it is using more resources. It is just a web application. In this case, as you mentioned, it's running WebSockets, so it is expecting real-time communication with an application. And since it is constantly running, it's consuming more resources. A function, it's a very specific application that it's executed on demand, and it's going to scale dynamically depending of the needs of who is calling that function, and is going to perform a computation and return a value. So even though you can use those two to solve the same problem, one is going to be more expensive and it's going to use more compute resources than the other. So functions is going to be good if you have like a very specific task that you need to execute and that you need that task to be elastic, pretty much scaling by demand. So if you just have one user calling this function, it's going to be just one execution. But if you have 1,000, it will be 1,000 executions, and that application is going to scale dynamically. The other application that is running, for example, on Heroku, it might not have the ability to scale automatically if you don't have that enabled. And since it is an application that it's constantly running, obviously it is constantly billing. So one it is by usage and the other one is just always running. And both solve different issues. If we bring these into cloud computing terms, a function, it is a function as a service. It is part of the serverless architecture. And an application running on Heroku, it will be a web application. It could be a microservice, but it is not considered part of the serverless architecture. If it is not clear, please ask again. It is a very, very good question. The other part of the question is, with a function, you don't need to worry about setting up authentication and authorization against a Salesforce org. It is already there. And the function, it is running on platform. Even though it is not running on the core Salesforce multi-tenant architecture, it is part of the trust boundary. So you don't need to set up any authentication. Heroku, you will need to create that authentication. So you will need to create authentication tokens, do OAuth or JWTs. It is going to be running on a different infrastructure. So that is going to be the main difference. One is for extending Salesforce applications with its Salesforce functions, and the other, sure, can do the same, but it will require way more work to do that.
And it's worth noting that there is also, if you're writing back into Salesforce, a separate API limit bucket for callouts, really. So if you're ever accessing any data from Salesforce or writing back into Salesforce from your function or from your server on your application on Heroku, that will then incur API limits against your total bucket of your Salesforce org, but it is kept separate with Salesforce functions.
Great point. Yeah. Exactly. Okay, I use the start function command from Visual Studio Code. The function is running. How can I trigger the function? So let's create a new file. I like to call this file payload. This is a JSON file. And I will, as it is specifying, I will set up empty JSON file. And then you can see a couple of buttons here. One says invoke and the other says debug invoke. If I click on invoke, it will invoke the function. So this is invoking the function from Visual Studio Code. And that's it. I'm getting the values. And if I want to go and debug and do like a step-by-step debugging from Visual Studio Code, I click on debug invoke, and that's going through the whole process. Perfect. So that's how can we create functions from the CLI, invoke functions from the CLI, and do the same from Visual Studio Code. That's pretty much represents the local development experience. Do you, Stephan, or any other from the Trailblazer community group or the chat has a question?
So we've written these functions. How can we then begin to start calling these from Apex? Do we need to deploy them to Salesforce before we can access them? Can we start writing Apex and accessing the functions?
Great question. And yes. So if we want to trigger a function from Apex, we need to deploy this function. And where are we going to deploy the function? This function is deployed to something called the compute environment. So this compute environment is the elastic cloud computing service that Salesforce has. So you can deploy these functions, and those are like within the trust boundary, and those will be able to be triggered from an org. So you create a compute environment that is connected to an org, and then you deploy the function. And after you deploy the function, you will be able to get an instance of that functions from Apex and trigger it. Let's do that. Let's do that example. Okay?
Great.
So 2 things to have in mind. This is very important. One, it's the project name. So if you see here on the sfdx project.json, we have a project that it's called AMA functions. Why this is important? Because the name of the function that is deployed, it's a combination of the project name and the function name. So we have the project name, AMA functions, and the function name, it's specified in the project.toml. So we have the my.js function, and we have the my.java function. So those are the 2 functions that we will deploy. Second, in order to deploy functions, we will need to have our project in a Git repository. So deployments are Git based, so you will need to have everything committed into your Git repository. It's a local repository. You don't need to have like GitHub or something external. It could be local. And that's pretty much it. So let's go ahead and create a compute environment, connect that compute environment to our org, and then deploy the functions. So how can we create a compute environment is using the sf command. So let's use the sf command, sf environment create compute, and let's specify the org that I'm going to be connecting this compute environment to. It's called AMA functions, and let's specify an alias, AMA functions env. The alias is for later use to query logs, for example. So let's create the compute environment. This works if you are logged in into Salesforce functions org. And let me see. I have an error here. The project can only contain numbers, letters, and non-consecutive underscores. Okay, so let's fix the name. Let's go ahead on the project JSON. Let's change this to an underscore. And let's try again. So how can I log in? Let me show how can I do login before doing this. So to log in, I will do sf login functions. It will open a login page. I will need to log into Salesforce using my credentials for that specific functions org. I log in. Now this is authenticated. Success. Beautiful. Now I am authenticated. Let me try to create the compute environment. I think the project is good, so it will work. Yep. Perfect. Now I have the compute environment created with the alias AMA functions env. I can execute sf env list to take a look at all of the different environments that I have. So this is not the best output here on my terminal, but I can use the other terminal, sf env list, which I have more space. There you go. I have like a bunch of different orgs, the Scratch org, and the compute environment we will use. Awesome. Second, I need to commit my functions. I need to commit my code. So let me create a commit. Git commit. This is going to be initial deploy. Awesome. And then I will need to do sf deploy functions to my connected org. So this will trigger the deploy of the functions to my compute environment connected org. And when this finishes, I will be able to trigger from that org. In the meantime, let's start writing some Apex, right?
Yeah. Well, I've got a question real quick. We have, let's see, we have Usam asking about scheduling a function and how to run it on a daily basis. And so what we're about to show you is how to write a function and call it in Apex. So call a function from Apex. There's nothing to stop you from writing a scheduler around that Apex class to schedule it on a daily basis, on an hourly basis, however frequently you'd like, using just the standard Apex functionality, and call out to that function whenever you need to.
Okay. Awesome. Thank you very much, Stephan. Okay. This is deploying the two functions, my JS function, my Java function. Meanwhile, this deploys. Let's create an Apex class. So Apex class, the name is invoke function. Store it on the default classes. I will need a static command so I can invoke it easily from the developer console. So public static, and it is like that, right? Public static. Let's do return a string. Let's do invoke. We can receive what? The name.
Yep.
And a payload. So we can make it like a little bit like generic.
Yep.
Perfect. And now this is the part that it's important. First, we need to get a reference of the function. So when you have access to a function's license, there is the function's namespace that it becomes available to you. So you can do something like functions, function, and get a function. It will be functions, function, get, and then you will need to get the function by name. Then you need to create an invocation of that function. And that is the function invocation class. And this is the function invoke, and then you pass a payload. So this is the synchronous invocation. You can also have an asynchronous invocation by passing here a callback. But we are going to be doing just a synchronous invocation. Then you get the response. So let's get the response, invocation, get response, and that's pretty much it. Let's return that response. We can make this a little bit better, right? If we do some sort of error message checking. So I will be copy and pasting my snippet so it's faster. So this is the basic one, but if we want to make it a little bit more pro, let's do some error handling here. This is 4 spaces, 4 spaces. I like everything. Okay. And let's change this into void so it's easier to execute on the developer console. Cool. So I am invoking the function and then I am checking the status. So it is an error and the error is not null. So I am getting a message. If not, I am just getting the response. The response is going to be a JSON object. And then I am printing out the JSON object. You can then serialize or deserialize this JSON into like an Apex object and do different other operations. We can show you on the sample application how can we integrate this with Lightning Web Components and Flow, so you have an idea how can you integrate functions within your projects. Okay, and that's pretty much it. Am I missing something here?
No, that's great. Nope. That should deploy.
Let's do something more organized, I think. Okay. Let me see how the deploy is going. Awesome. I created the 2 functions. Now it is deployed. What we need to do is push our Apex class. Right? It's force source push. If I am not wrong. Let's hope this works. Type is not visible, functions function. This is beautiful because there is a specific question on a Stack Exchange that solves this issue. And the issue is that the function's namespace, it is available on the API 53 on Winter 22. So when you get that error, just update the metadata to version 53 and try again. And now it will work. Awesome. Now I deploy the class, and I will be able to invoke it. For me, it is easier to do it on the developer console. Do you have an easier way to execute these Apex? So we don't need to think that much. Force org open. Okay. Okay, let me open the Scratch org. Let's go to the developer console. And in the meantime, do we have any other question?
We do. We have quite a few questions that aren't related to functions at the moment. So Afros wants to know how to protect against cross-site scripting. And Eugene would like to know how they're getting some errors after setting up Auth 2.0. Please ask those in the Trailblazer community, and we can make sure that we have the correct people there to answer the questions for you and hopefully be able to get back to you ASAP with those.
Invoke function, invoke. I think this is visible here, right? Or
yes,
no?
it should be.
It should be.
Mm-hmm.
So I'm calling the invoke function invoke. The first parameter is the function name. So remember, the function name is composed by the project name and the function name.
Yeah, and can you go back just to the function code real quick in Apex?
Yes. I'm missing something, right?
No, that looks good.
Okay.
Just wanted to check that.
And the payload is empty. Let's see if this execute and we have some logs. Okay, opening the logs. It is executing the function. And there we have an error. S object type account is not supported. If you are attempting to use a custom object, be sure to append the double lower score C.
Yep.
So this is great because we love errors when they happen live. When you are running functions locally, you are using the system administrator user. When you are running functions on the org, you are using the platform integration user. So you will need to add permissions. So let's go to permission sets. We have the functions permission set here. And let's go ahead and give permissions to the accounts object. So if you go to the accounts object, I don't have access. So let's do access. Let me increase the zoom a little bit. Let me give access to view all and read. And let's try again. Okay, the first execution failed. Now that I have permissions, if I execute, let's get the logs, invoke the function. There we go. I think we have a better output here. There we go. We have one record, which is the type of count with the fields ID and name. And that's how you integrate a function with Apex. And if you see, it doesn't matter if the function, I closed the debug window. Well, it doesn't matter if the function you are trying to execute is JavaScript or Java. It is the same code. So you can write your logic either in JavaScript or Java, and it will be pretty much the same code. Let me do the same with Java. AMA functions, my Java function, and I will be sending a payload, and the code is the same. So it is going to be exactly the same Apex code. So in the future, if for some reason the business logic that you wrote in JavaScript doesn't work and you are going to try any other library in Java, you can only create a new function with the same name, deploy it, and you don't need to change your Apex code. So this is a great feature and capability of functions. And you can see I'm having the same result, but here it's with a different output because in Java I gave a different shape for the output. I am just returning an array of accounts instead of the records. Okay, more questions? How are we doing in the chat? How are we doing in the Trailblazer community group?
Great. We don't have many new functions questions yet, but I had one.
Okay.
What can you tell us about the Functions Recipes app and how we can use that as a way to accelerate our learning?
I'm happy that you asked that question. So first, Functions Recipes app. It is available on GitHub. So you can go to github.com/trailheadapps/functionsrecipes. It is an application that has an integration between a Salesforce application and multiple different functions. So if you go to the functions folder, you are going to be seeing here a bunch of different functions, both in Java and JavaScript. And we also have an example in TypeScript as well. So you can see like how to write a function in TypeScript. And this is a great resource to learn about the different features of Salesforce functions. For example, the unit of work pattern. Here, if we go to the unit of work pattern example, you can see that we are doing multiple operations, creating an account, a contact, and a service case with some follow-up case within one single operation, one single transaction. So it's a good way to create transactions within functions. You can also see how to access information from an organization, how to perform different types of queries, how to access environment variables, how to use the logger, and how to process, for example, large pieces of information. This is a more complex example that is doing operations with JavaScript to show the compute capabilities of functions. What is good about this application is that you can navigate those examples and trigger those examples from the Salesforce app. And it also has integration with Lightning Web Components and a flow. So if you go to the classes folder, you are going to see, for example, the invoke process large data function, which is calling that process layer data JES function from an Apex, which is an Aura enabled function. So this is being triggered by a Lightning Web Component. And if you see the flow example, it's a little bit more complex. It is an invocable method. And we are also doing some serialization. The payload, we are going to serialize that object into a string. And we are also converting the output of the function into an Apex object as well. So you're going to be finding here a little bit more complex examples. I don't think I have a deployed version of Functions Recipes app to show you the interface, sadly, but you can go ahead and earn a badge on Trailhead with the Quick Start Explore the Function Recipe Sample app. And you will be learning more about the project. Here you can see a sneak peek of how this application looks like. So you have a list of the recipes, you have the implementation examples, you can trigger functions from this interface, you can take a look at the source code and learn more about functions here. Do you have anything to add?
No, I think it's a great accelerator and gives you some hands-on realistic examples of many different ways that you can use functions and really start to get started and learn how they really relate to Salesforce.
Yeah. There is the blog post we published a couple days ago. This has another example. This example, it's for local development, so you don't need to have a license. You can do it locally as well. It's pretty much using the Google APIs SDK to fetch information from YouTube. It's a great example to see how can you use third-party libraries to make external callouts to other APIs. It's pretty much this is getting some stats information from a playlist on YouTube, and it is using the unit of work pattern to store that information on a custom object in Salesforce. And from here, you can see pretty much a step-by-step tutorial how to create this application with the full source code if you want to take a look. And there is other examples here at the end on the resources of the blog post. There is another example that also works locally, which is a route planner using the travel salesman problem with Java. And this is connected to a Salesforce application using CDC events. So pretty much you can integrate also a function with platform events and CDC events as well. And this works locally. You can clone this, connect it to a Scratch org at DevHub, and you will be able to run this example and get results immediately on your screen and start learning about functions. This code is a little bit more complex. If you can see from here, this is using a third-party Java library called Grasshopper.js to use that travel salesman problem to calculate the fastest route from multiple points. And you can see how we implemented this solution here. It's also a great way to see how can you start fetching data from Salesforce and how to get that data and do some high compute operations to get a result and then store back that result into Salesforce. And this is also using unit of work pattern to be able to create those operations in Salesforce.
Cool. I mean, this is super helpful, Julián. Is there any last things that you wanted to say before we close out the session today? Or any resources you wanted to point people to?
There is a lot of different resources. You can go ahead to the documentation. It has a very good getting started guide. There is also, besides the blog post and the Trailhead modules, there is also a very good episode in our developer podcast, an interview I had with Jonathan Jenkins, one of the senior regional architects that was very involved with the functions project. You can go ahead, give it a listen, and keep connected with us. Subscribe to the YouTube channel, ask the questions on Twitter, and keep connected with us on the Trailblazers community group so we can continue this conversation. And I think that's it for now. We need to close. And thank you very much for joining us.